God bless you all. Unit 1 is measurement. Under measurement, we are going to study the physical quantities and unit, the first one. The second one is dimensions. And the third one is measuring instruments and scalar quantities and vector quantities. Okay, let's say physical quantities and units. A property which can be measured directly or indirectly in a physical system can be expressed as a physical quantity. Some of the quantities we may directly measure, and some of the quantities we cannot directly measure. So we have to measure or we have to calculate indirectly. For an example, if you take the length of this wood block, we take a length of the wood block, we can measure directly by a meter, by meter ruler. And the width of this also, or the breadth of this wood block also we can measure. And the width of this or depth of this wood block also we can measure directly. But what about the volume? So the volume we cannot measure directly. So the volume we have to derive by a formula, and we have to measure this volume indirectly from the directly measuring measurements. Of this length, breadth and height can be measured directly, whereas volume and density can be calculated. Likewise, when describing the motion of a vehicle, quantities such as a distance traveled by the vehicle in between 2 points, the time spent to travel that distance, speed, velocity of the vehicle, and acceleration can be. For example, if we are traveling in a vehicle, we can observe in the speedometer the speed of that vehicle or the velocity of that vehicle. But acceleration we cannot find. So acceleration we have to calculate separately from the directly measuring physical quantities. Okay. The next one is the measurements have a magnitude and a unit. Measurements have a magnitude and a unit, and sometimes as direction as well. For example, if you take a meter, in the international unit for measuring lengths have to be measured from a very small value to a very large one. The tabulation of below, you can see there are several objects within that range of measurements. Okay, the range of distance relevant of various objects we are seeing in this table. The first one is the diameter of proton. You may know the proton is a subatomic particle found in nucleus of every atom. The proton is the subatomic particle found in the nucleus of every atom. That range of the diameter is 10 to the power minus 15 meters. It's the very smallest particle. And the next one is the diameter of nucleus of heavy atom. The nucleus is the dense and the central part of the atom. You may know that the nucleus is the dense and the central part of the atom. That is the next range. That is in the 10 to the power minus 14 meter range. Let's say gamma rays. What is gamma rays? The gamma rays are the electronic magnetic waves. It's having higher energy and the shortest wavelength. It is the gamma rays are the electromagnetic waves. It has higher energy and the shortest wavelength. So normally the gamma rays occurring or the gamma rays will be emitted during the nuclear decay. So the wavelength of gamma rays is 10 to the power minus 12. So what is the average distance between atoms of crystalline solid substance? What is crystalline solid substance? Crystalline solid is a solid material. Actually, it's a solid material whose atoms, ions, and the molecules are arranged in a highly ordered and repeating pattern. Let's say a hexagonal pattern or circular pattern or any other repeating pattern. It's having a highly ordered and repeating pattern that extends in all these spatial dimensions. That extends in all three spatial dimensions. So in between those solid substances, the distance range is 10 to the power minus 10. The next one is the distance between air molecules inside a room. In the room, it is 10 to the power minus 8. 10 to the power minus 8 meters. And height of the child. Height of the child is almost 1 meter. And the height of 3-storied building, it's 10 to the power 1 meter. Normally, in a house or the single-story building, it is around 3 meter height almost. So if you take a 3-storied building, it will come around 10 to the power 1. So these are the ranges of distance relevant to the various objects. The next one is, in general, the measurements of mass involves relatively large value. Large value, though some are very small. Okay, for example, say galaxy. The galaxy. What is galaxy? Actually, a galaxy is a huge group of stars, planets, gas, dust, and the dark matter all held together by gravity. All held together by gravity. So it's like a massive city of stars floating in space. It's like a massive city of stars floating in space. Actually, our galaxy is called Milky Way. Our galaxy is called Milky Way. The sun is one of the star in the Milky Way. So if actually the galaxies are having many shapes, like spiral shapes, for example, elliptical shapes or any other irregular shapes. So averagely, one galaxy, the weight of the one galaxy or the mass of the one galaxy is 10 to the power 41 kg. One star, the weight of the one star is 10 to the power 32 to 10 to the power 28 kg. The sun, our sun mass is 10 to the power 30 kg. Our earth mass is 10 to the power 25 kg. Moon is the weight mass of the moon is 10 to the power 22 kg. Incidence, let's say, light to travel through an atomic nucleus. If a light is travel through an atomic nucleus, it takes time 10 to the power minus 24 seconds. Time for one revolution of an electron around the nucleus of inner orbit of a heavy atom, it's coming 10 to the power minus 20 seconds. The revolution is that much fast. Okay, lifetime of a human in seconds is 10 to the power 9 seconds. The time from Christian era to the present, it's around 10 to the power 11 seconds. So the next one is, we will see the International System of Units, that is SI units. According to the International System of Units, there are 7 basic quantities or the 7 corresponding units have been approved by the International System Units. Under the International System Units, there are 7 basic quantities and the 7 corresponding units have been approved. For example, these are the 7 basic quantities, that is length, mass, time, thermodynamic temperature, electric current, amount of substance, luminous intensity. Those 7 are the basic quantities in the under the International System of Units, and the corresponding units are meter, length for meter, mass for kilogram, time for second, thermodynamic temperature is Kelvin, and the electric current is ampere, amount of substance is mole, and the luminous intensity is candela. So the symbol of the units are meter is M, kilogram is kg, second is simple S, the Kelvin is capital K, ampere is capital A, mole is small MOL, candela is CD. There are other supplementary SI, 2 SI units are there. Those two are plan angle and the solid angle. The plan angle, the unit is calling radian, it's RAD, the symbol of unit. Solid angle is the steradian, is called SR. Okay, let's say now why we use the SI units. Why we use the SI units? The first one is global standardization. Global standardization. It means that to ensure the consistency in scientific and engineering. For example, if you take an engineering globalization, standardized globalization, in Japan, a mechanical engineer using a meter to design the engine or the motor car. Okay, that the same measurement in the Germany, one engineer or the assembler is using the same unit to assemble the design components in Germany. At the same time, one of the customer using in Sri Lanka for the operational purpose, he is using the same unit meter for his operational users. Applications are worldwide are essential. So the global, to make sure the global standardization, then consistency, we are using the SI units. You may know one of the NASA's climate, regarding the climate research, and this one NASA rocket was failed due to the mismatching of unit. So the unit standardization, global standardization is highly essential. That's why we have to follow the SI units. And the second one is ease of use. Normally the SI units we are using multiple of 10. So 10 to the power minus 20, 10 to the power minus 10, and 10 to the power 20, 10 to the power 30. Likewise, for the easy calculation, simpler. And the third one is precision and accuracy. Precision and accuracy. So we can give the measurements in precisely. Precisely we can enable high accurate and we can reproducible measurements. And the universality used in almost all countries, in Japan, wherever, if we are using the SI units, means all the engineers, commercial applicators, or scientists, all they have to use the same SI units. It is scalability also the fifth one. So those are the reasons why we are using the international standard units for our measurement purposes. Okay, let's see in the next class. We will continue the measurements in the next class.